Inverse Laplace transform of the following function. So our function is a sum of a lot of terms here. Okay, now we want to find inverse Laplace. That means a function in terms of t. Okay, just looking at these, I'm mentioning from the table. Just let's look at a couple of things here. We know that the Laplace of t raised to n is n factorial over s raised to n plus 1. That means Laplace of t is, t means t raised to 1, 1 over s square. Laplace of 1 is 1 over s. Okay. In fact, Laplace of any number is a number, any number, let's say 5, then Laplace of 5 will be 5 over s. Okay, Laplace of 1 is 1 over x, so 5 is 5 times 1, and you can go in this way. Okay. Then if there is a product like e raised to something, okay, by the way, this is negative, e raised to negative as and some function of s, in that case, that is the Laplace transform of ut minus a. That's the unit step function f t minus a. And these are like e to the negative as and some function. So I'm just bringing this up here from the table. Okay, so let's do it. Then uppercase h means the Laplace transform of lowercase h. That's the tradition. When you have f, the f of t, Laplace transform is f of s. Okay, uppercase in terms of, yes, that's the tradition. So the inverse Laplace will be h of t, inverse of this one 2 over s. I mean, this is easy, there is nothing to distribute. 2 over s, look at here. Okay, just 2. Laplace of 2 is 2 over s plus 1 over s squared, that's t. Okay, Laplace of t is 1 over s squared, just from this rule. Parenthesis not needed, plus. Now this is a product and there is no product rule. So we need to think in this way. This is one term and this is another term, right? So this is e to the negative s times 3 over s. I can pull 3, 1 over s. So I'm going to write in this way so that we can take inverse Laplace. Okay, so a little bit of work here. For this part, I'm going to write e to the negative s, 3 over s, I can pull 3 outside, 1 over s, 1 over s is Laplace of 1. Okay, Laplace of 1 minus, again e to the negative s, 1 over s square, e to the negative s, 1 over s square is Laplace of t. Okay, plus, again same thing, so we got two terms, e to the negative 3s, 1 over s is Laplace of 1, plus e to the negative 3s, 1 over s square is Laplace of t. Okay, I'm just setting this up so that I can apply this rule now. Okay, this one is equal to, okay, so I rewrote this one and I took Laplace transform. So just to be technically correct, I haven't done anything, so I'm going to rewrite this. Okay, this is pretty much h of s equals 2 over s plus 1 over s squared plus, I basically rewrote the function. Then now we can take inverse Laplace of this, which is ht. 2 over s, we already knew that's the Laplace of 2, plus Laplace of t, plus Now for this one, we will be applying this rule. Okay, so this e to the negative as comes out to be unit step function t minus a. This 3 is just constant 3. E to the negative 1s, e to the negative 1s, so u t minus 1, just the unit step function at 1. And L of 1, bring this to back. Okay, that's the just 1. If we had t, some function of t, that would be t minus a. Okay, this t becomes s, sorry, s becomes t, and that's t minus a, but 1 is constant, so just times 1. So no need to write anything here. I mean, times 1 not needed, minus. Here though, e to the negative s, like here from this one, when we take inverse Laplace, u t minus 1, oh, that's t, but t becomes t minus a, so it's like this one, t minus 1. So u t minus 1, u of t minus 1, that's unit step function, times t minus 1 is a factor. So, okay, this is u of t minus 1 times t minus 1. Okay, don't multiply t minus 1 and t minus 1, it's kind of, they are together, but this is u of t minus 1 times t minus 1, plus same thing, this one becomes u t minus 3. L of 1 is just 1, no need to write when we take inverse Laplace, plus here is now u of t minus 3, and L of t, when we take inverse Laplace, is t minus 3. Again, this is u of t minus 3, this is a factor t minus 3, and you may have seen this one, sometimes we write u3t, that's the unit step function. There is another notation, u1t, this is u3t. Okay, alternative notation for unit step function. Anyways, this is the answer.